Hello. And the question I'm going to be working on today is rotational motion from chapter 12. So I'd like to start off by saying that this is my third time recording, so I'm going to have a few big ideas as well as the equation written down. And I also have the problem written down, just so I can make sure I'm within the correct time limit. So, starting off, there's three big ideas for this chapter, which is Newton's second law, conservation of energy for rotation, and conservation of angular momentum. And there is one main equation that we follow in this chapter, which is the kinetic energy initial plus potential energy initial is equal to the kinetic energy final plus potential energy final plus the change in other energy. For kinetic energy, there can be both translational and rotational energy, which is, for translational, it'd be 1/2 mvi squared plus 1/2, and then for rotational, it'd be 1/2 I omega I squared. And then for potential, it'd be the mass times the gravity times the y initial, which is the height. And then it would be equal to the kinetic energy final, which is the 1/2 mvf squared. That'd be the translational. And then for the rotational, it'd be 1/2 I omega f squared. And then for this type of problem, we would have 0 as our change in other energy, such as nuclear, chemical, or thermal. So, our problem says, calculate the moment of inertia of a skater given the following. The 60-gram skater is approximated as a cylinder that has a 0.1110 radius. So we can say the mass is equal to 60 kilograms. And to find the moment of inertia, we have to refer to the table we were given. So if we go to that table, it says for a cylinder, the moment of inertia is 1/2 mr squared. So if we do 1/2 mr squared, we would get 1/2 of 60 times the radius, which is 0.110 squared. That would be equal to 0.363. So the moment of inertia of the cylinder would be 0.363 kilograms meter squared. That would be the units of this question. And then our second question says, the skater with arms extended, approximately a cylinder that is 52.5 kilograms with a 0.110 meter radius and two 0.900 meter long arms, which are 3.75 kilograms each and extend straight out from the cylinder like rods rotated about their ends. So, for this question, we would have the girl, for this question, we would be finding the moment of inertia for the girl along with both of the arms. And like it said in the question, the arms would be considered rods rotated about their ends. So, for this question, we drew out a cylinder with the radius of 0.1110 right here. And we also drew out from the center arm 1, which consists of here to here, here to here, and arm 2, which consists of here to here. So, for both of them, they would have a length of 0.900 meters, and then the mass would be 3.75. Oh. Kilograms. So, for this one, we would have to find the moment of inertia for the cylinder as well as the arm, or both arms, in which case the numbers are identical. So we could find the moment of inertia of one arm and multiply that by 2. So we could say the moment of inertia of the cylinder would be I equals 1/2 mr squared, which is equal to 1/2. The mass of the cylinder would be 52.5. and then the radius would be 0.1, or 0.110, sorry, squared. So that would be our moment of inertia of the cylinder, which is 0.317. As well as the moment of inertia of the arms, which, if we go back to our picture, we would see it is the rod pivoted at one end, which is 1/3 ml squared. L squared is equal to 1/3 the mass, which is 3.75, and then times the length, which is 0.9 squared, which is 1.0125. And because it's a moment of inertia for one arm, and the other arm also has the same mass, only in this case can we multiply the mass, or moment of inertia, by 2 for both the arms. So I would say moment of inertia of arm 1 plus arm 2. So that would be 2.025. So the moment of, or the sigma I would equal the moment of inertia of the cylinder plus the moment of inertia of arm 1 plus the moment of inertia of arm 2. So if we plug that in, sigma moment of inertia is equal to 0.317 plus 1.025 plus 1.0125, and this would equal 2.342. 3426, which was equal 2.343. And again, the units would be kilogram meter squared, because we're referring to moment of inertia. So that would be the total moment of inertia of the whole skater. So just to recap, for part A, we were asked to find the inertia of just the skater without the arms. So here's the skater on the left-hand side, and we were asked to just find the moment of inertia of the body, which was considered as a cylinder. So that's why we took the formula of the cylinder, which is 1/2 mr squared. And then for part B, which is right here, we were asked to find the total moment of inertia for both the skater, which is the cylinder, plus both of the arms. So that's why we found the moment of the moment of inertia of the cylinder, which is right here, as well as for both of the arms, which is right here. So this is the cylinder that I'm circling in green right now. And this is for both of the arms that I'm circling in red. And if you add those two values up together, you get 2.343 kilograms meter squared.